Okay, and then mixture problem solving. Okay, you're going to see a lot of percents in this. I have $30,000 to invest in two things, a savings bond and certificates of deposit. Savings bonds pay out 5% interest, while certificates of deposits pay out 7% interest. If I want to earn exactly $1,760 in interest, how much should I invest in each? So I don't really worry about the labels down here because when I see these percent mixtures of more than 1%, I know I'm going to use my table. Okay? But the table on percents is labeled differently. Okay, so write your percents, 5%, 7%. And if there's not another percent, it's your total. And then all you do is put the only unit you have is money and then your percent. The bottom row works itself out. So 5%, 0.05, and 0.07. Got to get the zero in there if it's a single digit percent. Okay, now the only money, and I can cross those out now. Now I see $30,000, but it doesn't say what percent that's in, so it can't go in here, and the same with that one. So I guess I don't know either one of these, nothing about it. And now the total money. Now this total money here is before I take the percentage out of it. So it would be the whole money amount. So it would be the larger of the two. So $30,000. That's before you apply the percents. Because when you take part of it out, you're going to end up with a smaller. So I'm taking 0.055% out of X, 0.07Y. And then those together take $1,760. Okay, so I need my chart here to get my first answer anyway. So X plus Y equals 30,000. And I got 0.05X plus 0.07Y equals 1760. Okay, so I'll be multiplying the top by 0.05. So I get 0.05x plus 0.05y. Then I take 30,000 times 0.05. That's 1,500. Okay, and the bottom, 0.05x plus 0.07y equals 1760. Okay. Now the bottoms all become negative. Now remember with these decimals, I would plus them on your calculator. So 0.05 plus negative 0.07, negative 0.02y. Then 1,500 plus negative 1760 is negative 260. Now you need to divide by that whole decimal. So I take negative 260 divided by negative 0.02. And that's 13,000. Okay. Now you're wondering how to label that. Because usually we got the labels down here for the answers. So Y is, it's money. Okay. And put what percent that came from. So $13,000 is put in at the 7% interest. And then I'm going to put 13,000 there because I know I can just take 30,000 minus 13,000 to find the X. And that's 17,000. Again, you just minus. Okay, so 17,000, and that's at the 5%. Okay, there we go. Number 2. The manager of a store that specializes in selling tea decides to experiment with a new blend. She will mix some Earl Grey tea that sells for $5 per pound with some orange pekoe tea that sells for $3 per pound to get 100 pounds of the new blend. If all this is sold, they will make $450. How many pounds of each tea is required? So we're finding pounds, but it's of two different things. Pounds of tea, but there's two kinds. Pounds of Earl Grey, put EG, and pounds of the orange pekoe or whatever, OP. Okay, so that's 2 units because I got the 2 answers and then the money amount. Pounds of Earl Grey, pounds of orange pekoe, and then the money. So that's 3 units. Now, I'm not dealing with percent, so I'm going to go old school on the labeling of the table. So, Earl Grey, Orange Pekoe, and total. How many? The cost of a single unit and the cost of a total. Okay. Okay, Earl Grey, what would that cost? Well, $5 per pound. That's for a single unit, so $5. Orange Pekoe is $3. Okay, now up above, the only non-money thing I see is 100 pounds, but it doesn't say if that's Earl Grey or Orange Pekoe. Okay, so 100 is your total, and then these will be X and Y. Okay, and then your total money amount is $450. Probably want to put that there at the beginning. So you get 5X and 3Y. So it's pretty simple, kind of old one. So we got X plus Y equals 100. 5X plus 3Y equals 450. So I times all these by 5, and these would be 1. So 5X plus 5Y equals 500, and then 5X plus 3Y equals 450. So these all go negative. So I add these, I get 2Y, and I add these, I get 50. So I divide by 2, and that's 25. Now I'm going to put 25 as your Orange Pekoe, so that's what you just put 25. The labels are already set up, okay? 100 minus 25 is 75, so the other answer is pretty academic from there. Okay, 2 more. Number 3 is a problem where the setup can be tough, but the act doesn't take a lot of work. A coffee manufacturer sells cinnamon coffee for $7 per pound, vanilla coffee for $10 per pound. At the end of the month, the cinnamon coffee had 30 pounds remaining, so the store manager decides to mix the 30 pounds of the cinnamon coffee with the vanilla coffee. He sells a mixture for $8.50 per pound, so kind of between the two. How many pounds of vanilla coffee should be mixed to ensure no change in revenue? So it says pounds of vanilla coffee. Okay, that's your only answer. But there's 3 units because you have the pounds of your vanilla, the pounds of your cinnamon, and then the money itself. So again, old school table, not the percent table. So I've got total, how many, and single and total. Okay, so I've got the vanilla and the cinnamon. Okay, so vanilla, how much that costs for a single pound of it? Well, that's going to be $10. And the cinnamon is 7, so let's cross those out. Okay, now look for non-money numbers. 30 is the only one I see. Now that's cinnamon coffee, so that would just be the exclusive cinnamon. And I can cross out both 30s. It's just a repeat of the information. And then X is vanilla. That's the only thing I don't know. Okay, so I'm going to have... The only thing I see left is $8.50 per pound. Now that goes in single unit because it says per pound, but that's the mixed together kind of. Okay, should say it's more together than it is total. So I've got 10x. 30 times 7 is 210. And it'd be nice if I had something to go here. Okay, so I can multiply 850 by it, and I can take x. Just put x plus 30, not 30x, so because you're not timesing them, you're adding them together. All right, so it's like the distributed property. We need to do 2 multiplications. So 1x times 850 is 850x, and that's 255. So what I really want to find out is if I sell them separately and add the profit together, when's that going to equal if I sold them together? Okay, so 10x plus 210 equals 8.50x plus 255. Okay, so I subtract 850x from both sides. That's 1.5x plus 210 equals 255. Then I subtract 210 from both sides, and 1.5x equals 45. And I'll divide by 1.5, and that's 30. So 30 pounds of the vanilla. 30-30 mix. Okay, and then number 5. In chemistry class, you have a combination of 1% hydrochloric acid solution and 5% hydrochloric acid solution. You need 100 milliliters of a 3% hydrochloric acid solution. How much of each solution should you pour in the mix? Okay, now we're back to the percentage mixtures. Okay, so put your percents. You have 3 of them, so you put your smallest, and you mix that with your biggest. It's the only mathematically possible way you can end up with a mixture in the middle. Okay, so percent, and the unit in the problem, 100 milliliters, so milliliters would be that. Okay, so my percent row, 0.01, 0.05, and 0.03. Okay, now they want 100 milliliters of a 3%, so they need 100 of this, and they want to know how much do we have to pour out of this, and how much out of this. So that is going to be 0.01x, that's going to be 0.05y, and that's going to be 3. Okay, so x plus y equals 100. 0.01x plus 0.05y equals 3. So I'll be taking this 111, 0.01, 0.01, 0.01. Okay, so that's 0.01x plus 0.01y, and 100 times 0.01 is 1, and then the bottom will be 0.01x plus 0.05y equals 3. These cancel out, and you take 0.01y plus negative 0.05. I'm going to use my calculator because I would not want to make a mistake to screw up the whole problem. That's negative 0.04y. Then add those 1 to negative 3, it's negative 2. Okay, and then I divide. Whoops, negative 2 divided by negative 0.04. I got 50. Okay, so I got 50, and that's at 50, and just put ml at 5%. Okay, now I just take 50. Well, 100 minus 50 is 50, so x is also going to be 50. So 50 at 1%, ml. Okay.